process of taking carbon and clearstream CO2 from industrial and power plants and out of the air and around us and turning it into valuable products. This is innovation at work, and it's shifting our perspective on how harmful emissions can instead be harnessed and put to good use. And what a timely discussion, given that today is Earth Day, to talk about this intersection of climate solutions and economic potential. I look forward to hearing from our panel of witnesses about barriers to scaling up these opportunities and the ways that we can support the advancement and deployment of carbon utilization. Congress has made significant efforts in recent years to support carbon utilization technologies and projects. In order to get CCUS deployed at the scale we need, it is critical that we invest in research, development, demonstration, deployment of the entire CCUS value chain, from capturing CO2 from coal and natural gas power plants and industrial facilities to utilizing or sequestering that CO2. That's why the Energy Act contained over $6 billion in authorization for CCUS, including over $280 million specifically for carbon utilization, including coal to products demonstration projects and a new carbon utilization research center. As chairman, I'm committed to ensuring the implementation of those provisions. We need to couple these efforts with necessary modification to the 45Q tax credit to really incentivize in deployment of these projects in advancing legislation like the SCALE Act, a comprehensive CO2 infrastructure package that I was pleased to co-sponsor and happy to see included in President Biden's infrastructure plan. Nearly all studies have examined the potential pathways to net zero carbon by 2050, have found a need for significant amount of carbon capture and carbon removal. Dr. Briol of the Nonpartisan International Energy Agency has consistently said CCUS could be the most critical technology for us to invest in to meet our climate goals. I'm proud of the work that National Energy Technology Lab, NETL, based in Morgantown, West Virginia, is doing under the leadership of Dr. Brian Anderson, one of our presenters today, to lead the way in CCUS efforts and the development of technologies to use coal in new ways. So I want to welcome Dr. Anderson. I look forward to hearing more about the innovative work being done at NETL. Carbon utilization has substantial economic, environmental potential and should be a key part of conversations around economic revitalization. By 2030, the CO2 utilization market size for products like concrete, fuels, and chemicals has potential to reach over $800 billion. This would represent about 7 gigatons of CO2, equivalent to 15% of global emissions. In addition, the use of coal as feedstock to produce high-value products is a promising field. These new uses for coal can produce products superior in quality and durability to conventional ones, including certain lightweight, high-strength building products and materials like carbon fiber. The demand for carbon fiber, graphite, and graphene will experience double-digit annual growth in the years ahead. These new uses for coal also have potential to provide new economic opportunities and revitalize traditional energy-producing communities who have been hit the hardest by the energy transition. Ramaco Coal is leading the way in development of coal to products, and I look forward to hearing from Mr. Randy Atkins about the work that they're doing. Carbon X Prize. I'm heartened by the commitment to carbon utilization shown by industry and research partners. I'm pleased to welcome two of our witnesses who were involved in the Carbon X Prize, a 5-year global competition that challenged innovators to develop breakthrough technologies to convert CO2 into high net value products. Teams across the globe participated and demonstrated the value of CO2 in a wide range of products, including alcohol used in vodka, hand sanitizers, plastics and batteries, and even toothpaste. Mr. Jason Beggar is the managing director of the Wyoming Integrated Test Center, which provided the U.S. site for this competition. And Dr. Agura Sant is the founder and chief technology officer of Carbon Built, who just this week was announced as one of the 2 winners of the X Prize for their work to embed industrial CO2 emissions into concrete, helping reduce the carbon footprint of concrete by more than 50%. So congratulations to Dr. Sant. I look forward to hearing more about your technology experience and the future opportunities for this breakthrough technology. In closing, let me reiterate the tremendous potential of carbon utilization to support our environmental and economic objectives. We have an incredible panel of experts with us today who are directly engaged in developing these technologies, and I look forward to this conversation. With that, I'm going to turn to Ranking Member Senator Barrasso for his opening remarks.
Well, thanks so very much, Mr. Chairman, and I'm delighted to be here with these wonderful people who are going to be testifying and sharing their thoughts and ideas with us. You know, the International Energy Agency has repeatedly stated that if the world is going to meet its goal in addressing climate change, we will need carbon capture, utilization, and storage, period. Earlier this year, the executive director of the International Energy Agency testified before this very committee in this room that carbon capture is an extremely important technology for reducing carbon emissions. That's why I've been a long champion of carbon capture technologies. In 2008, I introduced a bill called the Greenhouse Gas Emission Atmospheric Removal Act. I did this along with former chairman of this committee, Senator Jeff Bingaman, Democrat from New Mexico, who was Senator Heinrich's predecessor on this committee. More recently, I've worked successfully with a bipartisan group of senators, including Senator Manchin, our chairman, to expand the 45Q tax credit for carbon capture, utilization, and sequestration. Last year, along with a bipartisan group of senators, we successfully worked to enact the Use It Act. The Use It Act supports carbon capture, utilization, and sequestration technology. It expedites the permitting of important infrastructure like carbon dioxide pipelines. It helps researchers find commercial uses for captured carbon dioxide emissions. Carbon dioxide emissions can be transformed to create numerous products, including clothing from carbon foams, carbon fiber, building materials like cement and concrete, and even, as the chairman mentioned, hand sanitizer. And of course, Wyoming is on the cutting edge of carbon capture research and innovation. In 2018, the state of Wyoming joined with several rural electric cooperatives to open the Integrated Test Center in Gillette, Wyoming. The Integrated Test Center provides space for research teams to test carbon capture utilization and sequestration technologies. The center gives these teams the opportunity to use carbon dioxide emissions directly from Basin Electric's coal-fired power plant in Gillette. I toured the center several times, always impressed by the projects underway at the facility. Last summer, we actually had a Senate Environment and Public Works Committee field hearing at the center. After the hearing, research teams provided hands-on demonstrations of their groundbreaking work, and one of those teams was Carbon Built, who is being represented here today and recently won the prize, as you just mentioned, Mr. Chairman, the X Prize. Carbon Built used captured emissions in its concrete manufacturing technology. It was a finalist for the Carbon X Prize, a research competition to drive innovation in carbon capture, utilization, and sequestration technologies. And on Monday, the Carbon X Prize announced its winners, and Carbon Built was among them. Mr. Chairman, I'll point out I got an email last night from Senator Whitehouse. He had joined you and me and Senator Cantwell when we visited one of the teams that was working as well on doing exactly that part of research. They competed. The team that is here today was the victor. So we've been following this closely, you and I have, along with Senator Cantwell, Senator Murkowski, and Senator Whitehouse. So we're delighted to have the founder of Carbon Built, Dr. Sant, who has joined us here today, and congratulations again to you and your entire team. You know, earlier this month, newspaper Gillette, Wyoming, Gillette News Record did a story called Case Study. Integrated Test Center has potential to be prominent in CO2 research breakthroughs. The picture, as you'll see, Dr. Sant, is of you may not be able to see it, but I know you've seen it before, of Aman Medapur of Carbon Built, walking where the work has been done in Gillette at the coal-fired power plant and the carbon capture facility. The end of the article, the author, the newsman, reports, the world needs an important and often overlooked Wyoming natural resource, innovation. And that's what you and I have talked about, Mr. Chairman, the need for innovation in the work as opposed to regulation and taxation. So these are great opportunities for coal-to-product technologies as well. We have someone to testify to that today. Raw coal can be mined, treated, and refined to separate the carbon content and then used in high-tech, high-value products. These products include carbon fiber, activated carbon, and graphene. Last year, Mr. Chairman, you and Senator Capito and I introduced the Coal Tech Act. It stands for Creating Opportunities and Leveraging Technologies for Coal Carbon. Our legislation directs the Department of Energy to initiate pilot programs to help bring coal-to-product technologies to market. So I'm very pleased to see that key sections of our bill were enacted as part of the 2020 Energy Act. So today, Mr. Chairman, we're going to discuss the opportunities and the challenges facing both carbon capture and coal-to-products technologies. So before we begin, I want to thank you for putting this committee meeting together, and want to welcome Jason Beggar, who is the Managing Director of Wyoming's Integrated Test Center. Jason has testified before this Senate several times, including at a field hearing at our Integrated Test Center last summer in Gillette. Also like to welcome Randy Atkins, who is the CEO of Ramaco Coal. Randy is establishing a coal-to-products research facility in Sheridan, Wyoming. Finally, I want to thank all the witnesses for testifying and participating today, and look forward to the conversation.
Thank you, Senator. And with that, I'll finish the introductions here. We want to thank all of our witnesses for participating today, and I think it's going to be a very, very interesting and very informative hearing that we're having. It'll be quite hectic today. We have some votes coming up, but we're going to be going in and out, but we're going to keep this alive, and we'll have people by Webex, and we'll have senators coming in too. So I want to introduce Dr. Brian Anderson. Brian is a director of the National Energy Technology Lab at Morgantown, West Virginia. We also have Mr. Jason Beggar, the Managing Director of the Wyoming Integrated Test Center. We also have Dr. Gural Sant, Professor of UCLA's Institute of Carbon Management and founder of the Chief Technology Officer of Carbon Built, Inc. And then we have also Mr. Randall Atkins, the Chief Executive Officer of Ramaco Coal. So we will start today with Dr. Brian Anderson for his opening remarks.
Chairman Manchin, Ranking Member Barrasso, and honored committee members, thank you for this opportunity to discuss advanced carbon and carbon dioxide utilization technologies today. My name is Dr. Brian Anderson. I'm the director of the U.S. Department of Energy's National Energy Technology Laboratory, or NETL. Our research and development campuses are located in Morgantown, West Virginia, Pittsburgh, Pennsylvania,
Brian, can you
and
turn,
Oregon.
Brian, excuse me, on yours, you're going up and down. If you get your volume up a little bit or closer to your mic, I'm not sure. Let's try it again. We got so far, but just start talking again. We'll see if we can control it on this end. We're trying to get your volume up a little more.
Sure.
There we go. Now it's perfect. Perfect.
Okay, perfect. So our mission at NETL is to drive innovation and deliver solutions for an environmentally sustainable and prosperous energy future. We develop technologies to manage carbon across the full life cycle and have for many, many decades that enables environmental sustainability for all Americans. So today I want to discuss our decarbonization technologies and the opportunities that exist for advancing and deploying carbon and CO2 utilization technologies in the U.S. First, I'll speak to our NETL's advanced carbon products research. Our research to develop high-value products from coal aims to support communities that are impacted by the energy transition, both in past and in the future, and to help translate those skills that they have for advanced manufacturing jobs. We are converting coal into high-value carbon nanomaterials with the potential to reduce manufacturing costs and energy consumption while simultaneously improving performance. Coal is an ideal for producing graphene-type nanomaterials that can be used in electronics, composite plastics, batteries, water filtration systems, and 3D printing materials. We have also used coal-based additives to improve the strength of cement and concrete materials by 15 or 35%, which can be used to reduce building costs and the volume of construction materials. Our R&D on emerging carbon-based building materials is necessary to validate these materials as suitable for construction purposes, including ensuring compliance with the strictest health and environmental requirements for building materials from metals. So a few of our partnerships, we're partnered with the University of Illinois at Urbana-Champaign and Ramaco Carbon to use domestic coal to manufacture energy-efficient computer memory chips. This technology can be used to enable the next generation of artificial intelligence and machine learning, and I'm sure you'll hear more from Mr. Atkins on Ramaco's work. We're collaborating with XMAT in West Virginia to establish the utility of coal-derived building materials, licensed from their partner, Simplastics, out of Florida. The University of Wyoming researchers are collaborating with NETL to develop coal-derived carbon building materials from Powder River Basin coal pyrolysis products. Two of the building components can contain more than 70% carbon have been proposed. They're char-based concrete brick and another carbon-based structural unit. Finally, NETL has partnered with Seafoam in West Virginia to develop carbon foam panels and lightweight aggregates from coal at atmospheric pressure. There are coal-derived carbon foams that are being produced commercially via batch processes at elevated pressure, primarily for the use in composite tooling applications for the aerospace industry. Now I'd like to speak briefly about NETL's CO2 conversion and CO2 utilization research. Our carbon utilization research aims to develop technologies to transform CO2 into valuable products in an efficient, economical, and environmentally friendly manner. The emerging field of CO2 utilization encompasses many possible products and applications: fuels, chemicals, food and feeds, construction materials, enhanced resource recovery, energy storage, wastewater treatment, and many others. We have developed new catalysts that can use electricity to convert CO2 and methane into chemical building blocks and energy carriers. These inventions can allow the development of modular reactors that can use intermittent renewable electricity to produce carbon-negative commodity chemicals. We are partnered with the West Virginia University, the University of Pittsburgh, and Longview Power to develop and test at the laboratory scale an innovative technology to produce commercial quality sodium bicarbonate directly from CO2 from coal-fired power plant flue gas. In Dr. Sant's testimony, you'll hear about Carbon-Built's process to develop concrete blocks using CO2 from power plant flue gas without the need for the carbon capture step. It's been demonstrated by more than 1,200 hours of field testing at the Wyoming Integrated Test Center, represented this morning by Mr. Beggar. We're also working with Acadian Research and Development in Wyoming to synthesize a catalyst for the process to reduce CO2 to synthetic graphite. As discussed in the intros by the chairman and ranking member, full decarbonization of the electricity sector by 2035 will require a combination of renewable resources, energy storage, and reliable low carbon generation to assure reliability and affordability in our electric sector. Dispatchable fossil energy with CCUS can play an important role in conjunction with grid-scale energy storage for grid reliability during the energy transition. Our carbon-reducing technologies are critical to managing carbon emissions in industries beyond electricity, such as oil refineries and facilities that produce hydrogen, ethanol, cement, or steel. In addition to carbon-reducing technologies, negative emission technologies, such as direct air capture and storage or bioenergy with CCUS and mineralization, will play a pivotal role in managing carbon in the long term. We've been developing plans for a direct air capture center for evaluating emerging technologies in direct air capture. So in conclusion, science, technology, and research are powerful drivers of innovation and sustainable economic growth. Thank you for the opportunity to discuss some of these cutting-edge innovations which have application within and well beyond the energy sector. Thank you.
Thank you, Dr. Anderson. And next, we're going to hear from Mr. Jason Beggar.
All right. Chairman Manchin, Ranking Member Barrasso, members of the committee, I appreciate the opportunity to speak to you today. My name is Jason Beggar, and I'm the Managing Director of the Wyoming Integrated Test Center, which is a private-public partnership between the state of Wyoming, Basin Electric Power Cooperative, Tri-State Transmission and Generation Association, and the National Rural Electric Cooperative Association. The ITC is the largest post-combustion research facility in the U.S. and is located at Basin Electric's Dry Fork Power Station. It is important to remember that post-combustion technologies are not just for coal plants. They can be utilized at other industrial facilities such as cement plants and steel smelters. There is a significant need for these processes in non-energy applications. All ITC funding has come from the state of Wyoming and our utility partners. While we believe there is an important role for the federal government to play in advancing technology, and we would welcome such a partnership, no federal funding has been utilized, although some of our research tenants have received DOE grants to conduct their projects. CCUS requires both the capture of CO2 and then permanently doing something with it to ensure it is not released into the atmosphere. The ITC is unique in that it can host both types of technologies. Two important considerations for CCUS technologies are the amount of CO2 utilized and the cost of the process. For things such as EOR, geologic sequestration, and mineralization, the CO2-rich flue gas generally only needs to be captured and compressed, plus they can utilize vast quantities. Other technologies can be much more expensive. CO2 is a very stable molecule with a double covalent bond, so for technologies needing to break apart the atom, this requires a lot of energy, leading to higher costs. Nonetheless, all are important, and we need many options to successfully utilize large volumes of CO2. As was previously mentioned, the ITC hosted the Energy COSIA Carbon X Prize. But we are also working on a joint project with the government of Japan and Columbia University, taking CO2 and fly ash to produce carbonates, which have a variety of industrial uses. One application is silica, which is used to create polysilicate, a critical component of solar panels. Currently, 80% of the global supply originates in a region in China with serious human rights concerns. It is possible we could use CO2 from a coal plant to produce components for the renewable industry. While programmatic funding is extremely important, Congress also needs to provide the means to carry out these projects by supporting the places where research can occur. NETL and the National Carbon Capture Center are great research facilities, but limited in size. And DOE has been sending American developers with U.S. taxpayer-funded grants to test in Norway because there was not a facility large enough to test in this country. The ITC can host larger projects at better value to taxpayers with some additional infrastructure. We have the perfect blank canvas. Now we need to fill it. There is no better place than Wyoming to conduct this type of research. We have the facilities, suitable geology, regulatory agencies with expertise in regulating CO2, and a get-yes mentality towards permitting, a supportive legislature and governor, and lastly, public support for these types of projects. 14 years ago, Apple released the first iPhone, which came with 4 gigs of memory, a 2-megapixel camera, no flash, no zoom, no video camera. Today's iPhone 12 has 512 gigs of storage, facial recognition, 4 cameras, and HD video recording capabilities. Yes, today's CCUS technology is still evolving, but as we know, technology gets better and less expensive over time. We need to think about energy technology as we do with the things we utilize every day and appreciate how early government support made them possible. Touchscreen glass, a staple of today's smartphone, was developed in the UK in the 1960s for air traffic control applications. GPS, canned food, microwave ovens, the internet, microchips, vaccines, and nylon are all items developed by federal research. Technology is apolitical, and the U.S. can make its greatest impact by investing in the knowledge that can be utilized around the world. Technology is the best way to ensure these countries have access to power while meeting environmental goals. I appreciate the opportunity to speak with you today and will gladly answer your questions. Thank you.
Thank you, Mr. Baker. And next, we're going to have Dr. Gural Sant. I hope I pronounced that right, sir. I'm sorry if I hadn't.
Close enough.
Am I close? Am I close?
Very close.
Thank you.
So, of course, Chairman Manchin, Ranking Member Barrasso, and members of the committee, thank you for having me here today. There are 5 things that I want to really try and highlight. So number 1, of course, carbon dioxide utilization is really a key part of achieving our carbon reduction goals. This is foremost for its ability not simply to provide a revenue accruing and a cost-effective pathway, but it's potentially one of the soonest pathways that we can really catalyze for carbon management. Second, when we think about really expanded investments, we've got to think about expanded investments in carbon capture, utilization, and storage across the entire life cycle. But particularly, I think what it's important to highlight is to really place a special focus on grant-making mechanisms that support full-scale commercial demonstration plants. These demonstration plants are needed particularly not only to de-risk technologies and retrain our workforce, but particularly to gain operational, maintenance, and production management experience with new processes at relevant scales. This is something that we've done in an extremely limited manner so far, and this is something that needs to be greatly expanded. Importantly, this kind of experiential familiarity is extremely important to diffuse U.S. technologies across the world to enhance our competitiveness. We've looked at the idea of transforming carbon dioxide into concrete, and this is really, in our opinion, an extremely effective approach for carbon utilization for a couple of reasons. Number 1, the enormous scale of the construction industry, the relatively simple chemistry that's offered with this conversion, and the permanence of immobilization. And I think this is something that we really want to highlight, that when we think about carbon dioxide utilization, we want to think about permanence and the durability of immobilization as important aspects of carbon management. Carbon Built, a spin-out company from UCLA's Samueli School of Engineering, is commercializing a technology of the sort that converts carbon dioxide into concrete. And importantly, like Dr. Anderson just pointed out, it does it without a need for a carbon capture step. This work, which has been funded by the Office of Fossil Energy's carbon utilization and carbon capture programs, is invaluable when we think about infrastructure renewal and infrastructure construction in the United States. And the reason is really simple, because if we can enable construction at a really large scale with low carbon concrete, This is a significant and a catalytic means to create carbon dioxide utilization as a mainstream market opportunity. Fourth, we want to think about strategic government actions. And strategic government actions are really required when we think about how we would catalyze some of these markets. By strategic government actions, I'm particularly alluding to the need to ensure low carbon procurement and purchasing in the form of buy clean type of ideas, buy clean type of concepts, which look both at the cost and the carbon intensity of products and materials when we think about not simply construction, but the broader economy around us. In this regard, it's important to create incentives both for early stage innovative companies and established corporations. Historically, we've looked at ideas like a tax credit, and while a tax credit is a great way to offset a tax liability, for early stage companies, we need to look at concepts like a direct payment that's based on production capacity and production levels, really as a means to catalyze the sector. Furthermore, when we think about carbon dioxide utilization, we need to really think about 45Q. And when we think about 45Q in the context of utilization, we need to look at really reducing the cap on a qualifying project. The cap on a qualifying project, I think on the order of about 25,000 tons, is simply too large, and it needs to be reduced to a number on the order of about 2,000 tons to really make a difference for a utilization project. The reasons for this are really simple. We're likely going to achieve utilization in a small, delocalized manner across many different sites close to consumption centers, aka close to markets. It makes a lot more sense to have modular, smaller scale plants, which really are producing products and materials close to where they're going to be sold, because this is what minimizes transport costs. Particularly important when we think about commodity materials, things like concrete. The last thing I want to touch on is really a need for national databases. We lack national databases which have the tabulated data regarding the carbon intensity of materials and products, and which follow essentially a rigorous review and standardized procedures for assessment of carbon intensity. This is important not only for materials like concrete and steel and insulation materials, but it's important in general for products and services. These databases are important because they offer a credible, a technology-neutral, and an unbiased way to compare carbon efficiency, intensity, and improvements thereof, which really starts to give us an unbiased basis to rank and order materials and think about how incentives and credits could accrue as a function of the technology that's being deployed. Importantly, national databases of this sort are also important because they provide public transparency. And an important part of what we're really thinking about is really allowing consumers and purchasers to make decisions about the products and the services that they would buy, where if they wanted to buy low carbon products and low carbon services, they have the ability to consult a national database before making a purchasing decision. With that said, I'd like to conclude, and I'm happy to take questions as we go further.
Thank you, Doctor. And next and finally, we have Mr. Randall Atkins. Randall.
Senators of the committee, it is an honor to appear before you today, and I would especially like to thank Chairman Manchin and Ranking Member Barrasso, who are both from two states that I proudly call home, as well as where our companies have their operations. Coal today is basically thought of as a cheap, controversial, environmentally challenged fuel combusted in power plants. We look at the commodity, however, through an entirely different lens, in which it has a higher value purpose beyond energy, one, frankly, where coal becomes too valuable to burn. In our concept, coal simply stops being an emitter of greenhouse gas. Instead, it becomes an engine of economic progress and job growth for communities that are too often left behind. Today, I would like to discuss briefly a fundamentally new, environmentally positive use for coal, in which carbon derived from this commodity serves as a low-cost carbon feedstock for high-value advanced carbon products and materials. It replaces a role currently mostly served by petroleum. This field we call coal to products, and we have coined the phrase carbon ore to describe coal used in this manner. As an overview, I would refer the committee to the white paper that I chaired in 2019 to then Secretary of Energy Perry from the National Coal Council, entitled Coal in the New Carbon Age. Our advances for higher value uses for coal bar from developments in the United States from the early 20th century, when coal was the basic chemical feedstock. Today, however, most carbon products are made from petroleum feedstocks. These are almost 40 times more expensive than the same carbon equivalent contained in coal. We are also now substantially behind China in pursuing this path. The IEA estimates that China annually now uses almost 400 million tons of coal a year to produce chemicals, fuels, and fertilizers. Their new 5-year plan calls for the construction of 370 new plants, which will consume roughly 1 billion tons of coal by 2024. This is roughly twice the total amount of coal produced in the United States. We embarked on our effort roughly 8 years ago, encouraged by new technological developments in advanced materials and manufacturing. We have worked on grants for innovative carbon research with the Department of Energy. We have had an unparalleled partnership with the national labs, especially the National Energy Technology Lab in both Pittsburgh and Albany, Oregon, as well as the Oak Ridge National Lab in Tennessee. Today, carbon is becoming the dominant advanced material of the 21st century. Both Senators Manchin and Barrasso mentioned a number of the products involved. If we could take these new carbon products and make them for less money using coal, it could have a dramatic positive disruption on the cost structure of many products and industries, including infrastructure. It would also dramatically improve the environmental and qualitative aspects of many products and create lots of jobs. So what carbon products and materials are we currently pursuing? As I mentioned, they've been discussed, but they include graphene, graphite, porous carbon, carbon fiber, building products in a variety of forms, synthetic graphites, and of course, rare earth elements. Our recommendations are that we would ask for vastly more funding for both carbon research as well as for the national labs working with us. We would like equality under the 45Q tax credit provisions. And to implement these new technologies, we encourage ample funding and implementation of new carbon pilot plant facilities provided for in the Coal Tech Act. Indeed, this summer we will open in Wyoming the first research pilot prototype, which is pictured in my materials. As a main recommendation, however, I would encourage the development of what I call carbon camps. 100 years ago, my grandfather worked in a company store in southern West Virginia at what used to be called coal camps. I know both Senator Manchin and Barrasso were very familiar with their history. The 21st century version of CAMP stands for Carbon Advanced Material and Product Centers. These camps can repurpose older and existing mining areas across the country into new mine mouth, higher tech, net zero emission manufacturing hubs, which NETL has estimated might create as many as 500,000 new jobs. In conclusion, the United States possesses the world's largest and cheapest carbon reserves. It needs to capitalize on that advantage and develop its own form of a carbon valley to unlock that potential. I thank you deeply for your time.
Thank you, Randy. And now we're going to begin our questions, and I will begin. This is going to be for all of you, and we'll go down the line. We'll start with Dr. Anderson and just go down the same line as we did in speaking order. The President this morning set an ambitious goal of 50% emissions, as we all have heard, for reduction by 2030, which is extremely, extremely aggressive where we had been before. And I was glad to see specific inclusions of CCUS in the Nationally Determined Contribution, or NDC. As I said before, in order for carbon capture to thrive, we need to be thinking about the whole CCUS value chain, and including how to use the captured CO2, which is what you all have given your brief statements about. So we really need to advance all the many technologies that put captured CO2 to good use, whether that be in concrete, building materials, toothpaste, or more. So the question would be, what do we need to do to get carbon utilization to the scale we need to be able to support and widely deploy the CCUS to help meet this ambitious, very ambitious climate goal? Dr. Anderson?
Well, Senator Manchin, thank you for that question. I think that a lot of the direction or pathway toward meeting that goal comes to the reduction in the cost of carbon capture itself. So creating the low-cost feedstock of CO2 through driving down the carbon capture costs. We have some aggressive targets. We're sitting at around between $42 and $48 per metric ton of CO2 captured. We want to get to $30 per metric ton of CO2 captured to then provide that low-cost feedstock for the CO2 utilization that provides another mechanism for providing market value. Certainly then continuing the efforts that we're working on and discussing today to provide options to create other vehicles for funding the carbon capture effort, I think is also critical. So
I just want
cost of capture and conversion.
Thank you. I want to make sure I clarify. There are people that'll be saying that this is not feasible. We can't get that type of reduction in that short of a period of time, so that would mean you'd have to eliminate using all fossil. I don't believe that. I believe that we do have the ability and we do have technology if we are committed to investing in that technology and rapidly ramping up to meet this ambitious 2013. So I think, Mr. Baker, if you could start now with yours and see if, I just want to know if it's feasible.
Absolutely. We just need to be able to show at larger scales, and I think that's where facilities like the ITC come in. I think another area that we need to consider when we're thinking about this is federal lands and permitting. If we're going to be doing geologic sequestration, a lot of that's going to happen on federal
So we have to
land.
accelerate our permitting process and not put all the roadblocks and go through the court processes that takes 10, 20, 30 years.
Absolutely. We need to be able
Gotcha.
to move these things and permit them quickly, and right now, I don't see how you could go through an entire NEPA process to build a pipeline to sequester
Gotcha.
CO2.
Go ahead.
I think that we need to think about the whole chain, you know, capturing, moving it, utilizing it in a place like Wyoming where we have such a extraordinary volume or amount of federal lands. The federal NEPA process certainly creates barriers when we look at things like where we've got the Dry Fork Power Station to move that CO2 to places where it can be used and utilized. So I think that's really important, as well as the scale up to demonstrate
Gotcha.
that these things can work at a larger scale.
Gotcha, Doctor? Hunter?
There are three things I would touch on. Number one, I think we need to do large-scale commercial projects. We just cannot get away from this.
Can we scale up quick enough in order to meet these?
We can. What it requires is funding and sort of willingness to do
Gotcha.
it. The next thing that we really need is we need the creation of markets, and I think this is where the government can play a really significant role.
Okay.
We need buy clean purchasing mandates to really come about. The third thing that we need is we need permitting, and we need permitting not simply for sequestration, but also for utilization. And if we can couple this with the right kinds of incentives, particularly tax credits and direct payments, where we couple, as an example, carbon reduction goals with energy efficiency improvements or production efficiency improvements, there's much higher incentive to actually make a difference.
Thank you. Mr. Atkins?
Sure. Senator, I think if you're going to approach this problem with that kind of a time frame, you almost have to look at this like a Manhattan Project.
Correct.
Where you're going to devote a lot of resources from the federal and state level to try to accomplish something to really change both the market dynamics and the way a lot of things that we now take for granted are done differently. One of which, of course, I focus on, of course, is coal. So if we could have a dramatically larger shift away from necessarily using coal for power production and use it for a non-greenhouse producing function such as products, that would have a dramatically positive effect. And I think a number of the items talked about from both tax policy as well as funding for research are important components.
What I'd like to challenge, we're in a time, with that being announced today, and we want to make sure that we're part of the solution, not an obstacle. And those of us who come from fossil states, that, if the federal government's serious about this, they got to put their money where their mouth is, if you will. I would like for all of you all to be thinking about this as quickly as possible and get us a report back to this committee on what it would take and the sort of investments that would be needed and the practicality of this being done within that 2030 period of time. That would be very helpful to us, okay? With that, I'm going to turn it over to Senator Barrasso.
Well, thanks so much, Mr. Chairman, and thank you for your ongoing leadership and interest in all of this. Mr. Baker, one of the hallmarks of American ingenuity is our freedom to innovate. And, do you agree that innovation is a much better way to address climate change than regulation and taxation, and the fact that the United States is only, at this point, producing about 15% of the global emissions, and India and China are producing, their numbers continue to go up, even though our emissions have been, over the last decade, decidedly down?
Ranking Member Barrasso, I think you're absolutely right. I think if you can innovate and find market solutions that people rapidly adopt and take, you're going to find the process moves a lot faster than the stick of regulation, where you have to try to fit that round peg into that square hole.
And Mr. Atkins, you know, your National Coal Council report discusses the cost advantage of coal-derived carbon over existing petrochemical feedstocks. And just, you know, with the supply chains for petrochemical feedstocks pretty well established in the United States and around the world, how can we develop robust supply chains for coal-derived carbon here at home?
Thank you, Senator. Well, as I pointed out, there is really a dramatic cost advantage to coal. So there's the same amount of carbon basically in a ton of coal as there is in a ton of petroleum, except a ton of coal in Wyoming goes for $12 and a ton of petroleum goes for about $400. So you start right there with a distinct advantage. For the United States, we basically have the entire value chain and supply chain within our grasp. We have the resources, we have the talent, we have the mining talent, we have the technology talent. We have transportation and logistical advantages in coal-producing areas. If we can take advantage of those, that gives us a great deal of a head start toward trying to get those goals.
And then for all of you, and maybe we'll start with you, Jason, and then work our way all the way through. In recent years, financial institutions have considered something called non-financial factors, including environmental, social, and governance, when making investment decisions. So do each of you believe that financial institutions should consider carbon utilization technologies to be specifically compliant with these environmental, social, and governance considerations?
Ranking Member Barrasso, absolutely. You know, if the goal is carbon reduction, it shouldn't matter the flavor of carbon reduction, and should be applicable.
Dr. Sant?
I agree. I think it's extremely important that we factor financial considerations into carbon reduction, because if we think about the fact that, you know, we want to be able to decarbonize, we need technological pathways, and if those imply a cost, they also imply a cost not only to companies but also the financiers that finance companies.
Mr. Atkins?
Yes, Senator. Well, I spend a lot of time working with the financial community, and I would agree with you. They should follow those, and if they follow the science and the facts, they both would say that every molecule of carbon that is put into carbon product is one that is not put in the air. So I would totally agree with that.
And Dr. Anderson?
I would concur. I certainly agree that what we're trying to tackle is the emission challenge, and we need to have all the levers at our disposal.
Mr. Atkins, you know, using carbon and carbon dioxide as a feedstock in products, I think it's going to draw a lot of interest from consumers for environmental reasons. Yet these products really need to perform in a way that they could be priced competitively with existing products in the market. It's something that Senator Murkowski and Manchin and Cantwell and Whitehouse and I saw when we discussed these earlier research projects being done. So how do products made from coal-derived carbon compare with existing products in the market?
Well, first of all, they are both cheaper, they are qualitatively better, and in many cases they're stronger. As I mentioned, you know, coal enjoys a dramatic cost benefit over petroleum. So that starts the ball rolling, if you will. But when you get into some of these specific product lines, there's dramatic qualitative differences that improve the use of coal over petroleum in a number of these products.
And then finally, for Mr. Beggar, coal communities in Wyoming and West Virginia and other states have powered this nation for decades. The demand for thermal coal in the United States has been in decline, maybe for the foreseeable future. To what extent can coal-to-products manufacturing offset the economic and job losses in coal communities?
Senator Barrasso, I think for a lot of those communities, it's about keeping up volume. You know, a community that's built on a 300, a million ton per year sort of economy, or a community that has a million ton per year mine. What can you do to do things at volume? And so these products and projects and things that we do, I think we need to think about that to ensure that you still have the number of jobs and service or companies and everything supporting that industry. So there are applications and opportunities, but we also need to think about what the number of people that it would take to carry out those new industries.
Thank you, Mr. Chairman.
Thank you, Senator. And now we'll have Senator Heinrich.
Thank you, Chairman. I want to talk about a little bit about the declining cost curves. And, one of the things I've learned having grown up in a utility family, my dad was a IBW lineman at a time when all of our generation was coming from coal and hydro, is that, not all technologies decline in cost over time. And if you look at a coal-fired power plant, a thermal plant, or if you look at a nuclear reactor, because they have high labor costs, they have high permitting costs, they have a lot of uncertainty in their construction oftentimes, they tend not to decline over time. That's one of the reasons why we've struggled keeping our nuclear fleet going, even though it's firm carbon-free power. So what I want to get at is, like, why should we believe that we can push the costs of carbon capture and sequestration down when many of these projects have more in common with a thermal plant or a nuclear reactor than they do with an iPhone or a solar panel, where you have clear manufacturing-based cost declines? Mr. Baker, you look like you want to jump on that.
Senator, I think that's why we need to have a suite of technology options available. I think when we think post-combustion carbon capture, the ones that come to mind are, Petronova, Boundary Dam, which actually employ a solvent-based liquid. And there's actually a pretty significant, almost chemical plant that you build alongside that to conduct the heat reaction and capture and do all those things. But there are other types of carbon capture technologies out there. For example, we have a membrane technology to think reverse osmosis water. I mean, it can capture about 75 to 80% of the CO2 by utilizing a membrane.
And would you describe that as more of a distributed technology than a big centralized piece of technology, like, say, the Kemper County facility that failed after so many years of cost overruns and construction delays?
The promise of something like a membrane technology is it can be modular.
Yeah.
So, you just add on more modules as you need.
That's actually one of the reasons why I'm optimistic about direct air capture, is because it's also a modular technology. It doesn't have to be centralized. And so, Dr. Anderson, I wanted to ask you if you could speak a little bit about the role that Nettle's planned direct air capture center can play in pushing this forward as well.
Well, thank you, Senator Hunter. And if I might take the real quick time, we have also shown some considerable cost decreases over the last few years in carbon capture from point sources. So moving to second generation technologies beyond the aqueous amine solutions that Mr. Baker was speaking to, we've driven that cost down into the 40s when it started in the 70s. And so we're seeing those cost declines and see some serious promise. With regard to direct air capture, there are segments of the economy that are extremely hard to decarbonize. And so when we get to those segments of the economy and the industry and furnaces in folks' homes, and we need negative emissions technologies like that.
I'm going to stop. I would agree with you when it comes to decarbonizing industrial processes. In most cases, furnaces in people's homes can be replaced with electric heat pumps. And that's the most efficient way to get to zero carbon, is to power those electric heat pumps with clean electricity. But Dr. Sant, before I run out of time here, I wanted to give you a chance to talk a little bit about how you would structure a buy clean incentive for U.S. government to procure, for example, low carbon concrete.
So Senator Heinrich, really the important thing I think we want to really focus on when we think about buy clean is we want to think about cost, and we want to think about carbon intensity. Historically, with construction projects, we've thought about everything based on the lowest bid, and the lowest bid is an insufficient basis of procurement. We need to think about both cost and carbon intensity on an equal basis, and potentially even on a somewhat of a favored basis towards carbon intensity, to create the market for low carbon products. I think, of course, all of this imagines that you've got exactly the same engineering requirements that all products fulfill, but you use cost and carbon intensity as two levers that you can essentially adjust in making purchasing decisions. I think states like California are already moving forward with ideas of the sort. And you're starting to see that there's a response. Markets are starting to be thoughtful. And most importantly, consumers, even at an individual level, are starting to be thoughtful. And I think that's really how you catalyze change.
I'd be very interested in working with you on something of that sort. I do believe that, the power of the federal government through procurement to really be a huge entry into transitioning these technologies to a much lower cost, to a much wider application is part of how we solve some of these challenging problems.
So I agree 100%, and this is important not simply to think about how we think about a bid process, but it's important for how we catalyze production capacity and market demand. And all of these things have to work hand in hand because you need policy and manufacturing capacity and really a consumer response to all sync together. And so thinking about really good policy around it is important, and we're happy to help.
Thank you, Senator. Now we have Senator Langford.
Bill, thank you very much for your engagement in your research on all these issues. I do want to be able to dig a little bit deeper on how far we are on some of this research. And so this is really a question for Mr. Atkins, Mr. Anderson. Tell me, how close are we to being economical on trying to get rare earth minerals out of coal? Where are we? I know we're working on it a lot. We've talked about it a lot. Tell me, how close are we to making it economical?
So Randy, would you want to start or me?
Sure. We are now working with NETL's offices in Albany, Oregon, on assessment of rare earths and trying to essentially map out in the United States where rare earth deposits might be found. And the second part of the question, of course, is once we find them, how do we economically process them? I would say that in terms of finding them, we're much further advanced than we are necessarily in how we process them. And I think that's where probably a lot of research needs to be devoted. And Brian, probably since NETL is at the forefront of a lot of the rare earth research efforts, I'll let you speak to the processing side.
Sure. Well, quickly, Senator Langford, I can get you the exact numbers of where our projections are today. We have a number of projects from different types of feedstocks, including raw coal, but also from some environmental remediation projects like acid mine drainage sludge, which present a lower barrier to the concentration of rare earths. We are not to the point of economical competitiveness with the international rare earth markets, particularly dominated by the rare earth deposits in China, but we are driving the cost down as we scale up the processes from a number of different feedstocks. I can get you the exact numbers.
That'd be great. I'm not going to try to hold you to an exact number because no one knows the future but God. But give me a good guess on, are we talking 5 decades, 3 decades, 1 decade, 5 years before we start getting to that point based on current trends?
Based on the current trends, I think we're pointing toward a decade, but there's also some national security and implications of supply chain variety. So they have some domestic supply chains that it might be worth paying a slight premium to have domestic sources of rare earths and critical minerals.
Well, it is exceptionally beneficial to us to not be dependent on a communist nation like China for our rare earths. All of our development, rare earths and critical minerals are used in a lot of places, and we are exceptionally vulnerable at this point and dependent on a communist nation for our basic supply chain. I think is a terrible idea. And so developing domestic sources, I think, is exceptionally important, and this is an area that we need to continue to be able to engage in. I do want to ask Mr. Anderson the next follow-up question on commercialization. There's been a lot of conversation about continuing to be able to use carbon and road building and a lot of other projects, building materials. Some of those are in current use and that are common. Some of those are exploratory, and we may have a while on. So give me something that is aspirational at this point that's being discussed, but is not ready for prime time yet, and give me something that is currently being used and is economical.
Well, so one that's extremely promising is our coal to graphene materials for additives in cement. We've been able to drive down the cost of producing graphene by over 10,000 compared to the current value, which would enable high volumes of graphene to be produced and put into cements that strengthen cements for transportation applications. That's one that's aspirational, but we see a real pathway into the future. Some of the other areas that are being at the edge of being put into market are some of our work in building materials, as represented by some of the folks here today, as well as Simplastics. I mentioned Simplastics and XMAT project that has built a facility in southern West Virginia to make roofing tiles that are a replacement for existing ceramic roofing tiles that is on the verge of commercialization and scale up at the commercial scale with some tremendous success.
Great.
I might
concrete
add
side
on top
things.
of Brian's comment is that carbon fiber is another area that I think is going to be very critical, which is close to something that we might be able to have into the market within the next 2 to 5 years. It has a dramatic impact on infrastructure. It has a dramatic impact on lightweighting of vehicles, on planes, on military and other strategic interests. And that is an area that we've been working on with Oak Ridge National Labs, which is something that we feel should be promoted by the government.
That's helpful. Mr. Chairman, thank you very much for the time.
Thank you, Senator. And now we have Senator Cortez Masto by Webex.
Thank you, Mr. Chairman, the ranking member. Dr. Anderson, let me start with you. In your written testimony, you stated that the emerging field of CO2 utilization encompasses many possible products and applications. And then you went on to list geothermal energy as a complementary technology, cutting-edge research in carbon utilization. As you may be aware, Nevada is one of the largest geothermal energy producers in the country, and I believe we have significant untapped potential. Can you please expand on this and talk more about the ways in which both DOE and ETL are pairing carbon utilization and geothermal technologies?
So some early research in the national labs back in the 1980s were identifying CO2 as a potential geothermal fluid for use in engineered geothermal systems in the subsurface. It has some advantages over water because of its ability to carry energy and have lower viscosity in geothermal applications. It is one that is still an active research area. There has been limited field testing of using CO2 as a geothermal fluid, but the Geothermal Technologies Office in Energy Efficiency and Renewable Energy has continued to do some work on this. And in fact, in my own history as a researcher, I personally have done research in CO2 as a geothermal fluid, and it does have a tremendous potential to be coupled with regenerated, the amine regeneration facilities and the need for heat to use CO2 in the subsurface, produce geothermal energy, and subsequently decarbonize through utilization.
Thank you, Dr. Anderson. Let me ask Dr. Sant. In your written testimony, you called for the need to stage, support, and incentivize deployment CO2 utilization technologies in order to help industry transition and reduce CO2 emissions. So as the U.S. invests in carbon dioxide technology, how should we be looking ahead to ensure that domestic manufacturing and workforce training is keeping pace with the innovation?
Thank you, Senator, for the question. So really, I think there's 2 or 3 things that we need to think about. You know, historically, we've had a big focus on funding research and technology development to what I'd say is lower TRL, so to speak. And we need to really look at pushing up the TRL levels that we offer support to. So I think, you know, when we think about manufacturing, we need to think about really the funding of full-scale commercial plants, which allow us to do 2 things. Number one, they allow corporations to gain experience with operating and managing these new facilities and new processes, which are different from what they've historically done. I think what goes hand in hand with that is really the retraining of a workforce, because, you know, you need a workforce that's going to do things differently than have been done so far. All of this can really only come about if we are really funding the construction of these facilities and really putting them in place fast enough, because without having the early stage support that's needed to really have full commercial deployments, we're not going to be able to scale up fast enough. And I think this kind of sort of operational familiarity, experiential familiarity, really comes from the government stepping in to offer early stage support, because as it builds experience not only in the production, but also in the products. And these things will go hand in hand with worker retraining and sort of broader technology diffusion into the market.
So, and then when you talk about, because I do believe there's an importance here with the public-private partnership that is essential in helping deploy these technologies and ensuring that the industry is trained and prepared. And that is a key component of this. And I'm assuming as you're thinking about this, when you talked about government kind of stepping in the initial stages and incentivizing, but there is also this reliance on that public-private partnership. Is that correct?
Absolutely. All of these things have to follow a public-private partnership, and it has to go up and down the value chain, right? So we've got to think about manufacturing, but we've also got to think about the creation of these products, because having facilities that produce products that don't get used is not useful. And this is really where, being able to stage sort of a buy clean type of idea, where you really have these facilities that are producing products that go fulfill a buy clean agenda, sort of gives you complete coverage of the supply chain and the value chain. I think being able to sync these things together obviously requires government support, which is the public part, and bringing private corporations to a point that they're able to sort of really leverage that support in the best way to really create a market for products and services which are of a low carbon nature.
Thank you. Thank you, Mr. Chairman.
Thank you, Senator. And next we have Senator Cassidy by Webex. Senator Cassidy on? If not, we'll have Senator Murkowski.
Thank you, Mr. Chairman. You know I love these
I knew you were
hearings. But to be able to talk about the technologies and how we can utilize carbon. For so long we talk about carbon sequestration. Okay, that's good. We can put it back in the ground. But to be able to utilize it, to manage it, to make good stuff out of it is exciting. We had that great trip when we did our Arctic Codel and had an opportunity to go to the University of Aberdeen and to see there what they were doing with the various products, but just, again, better understanding what we can do with utilization. I'm going to start my questions off with you, Dr. Anderson, because I want to talk about something that I don't think has been discussed here yet this morning, and that's the potential that we have for utilizing, whether it's algae or kelp or seaweed, but the focus on what the oceans can provide. I have legislation that I've introduced with Senator Whitehouse, the Blue Carbon for Our Planet Act, which kind of focuses on the naturally captured and what is naturally captured and stored in the oceans, or what could potentially be utilized on our deep seabed for floors. But more interesting to me is to be able to look at something like kelp, be able to use that as that carbon sink, if you will, still have a market for a pretty extraordinary product. And so I'm interested in this kind of innovation in seaweed aquaculture. We're certainly seeing it in Alaska. The Center for Climate and Energy Solutions estimates that by 2030, algae-based products will be a $320 billion industry. And one of the advantages that I understand is that it doesn't require high-purity carbon dioxide feedback. It can be processed, converted to different products, everything for food for livestock and aquaculture feed to food products, chemicals, et cetera. So the question to you this morning, Dr. Anderson, and with all that you've been doing at Nettle, do you think that, am I just dreaming on this, that this is a great opportunity for us, but that with the potential for algae and other seaweed type matter, that we can economically cultivate and commercially scale to, whether it's fuel different alternatives, but create other valuable products? So your comments on what we might be able to do with these materials that are part of our ocean systems.
So a little bit over the past 2 years, or even really the past decade, we have had a number of projects specifically on using algae and using aquaculture for the capture of CO2. It's shown some promise, but also some challenges, as you were alluding to, in terms of economics. The economics of capture and pushing the CO2 through the aqueous system, and the growth profiles of the algae. However, a project at the University of Kentucky had shown some significant progress on making higher value, it's not vitamins, but higher value additives for animal feeds out of the algae process, as opposed to moving it into a fuels sector. So there's still a considerable amount of work and work we're doing at NETL as well as NREL on using algae for CO2 capture. In addition, we have with NREL and ExxonMobil a three-pronged collaboration where the attempt is to use the algae and bioaquaculture based processes with Exxon's expertise in scale up. And so it's in the early stages, but again, showing some promise, but no major economic drivers that I see at the moment.
Okay, we'll keep working on it. We're working on our end as well. You know, it's interesting because this morning I'm joining a large group of members. I think Senator Manchin, you're part of this, but the Growing Climate Solutions legislation that's being introduced today. So there's a lot going on. I think where we're looking at these new and innovative ways, whether it is producing building materials or whether it is food for livestock. But it's a good point for us to be at. So how we take that next step? Lots of good work going on. Dr. Sant, I want to congratulate you and your team for winning the Carbon X Prize. Pretty cool. I guess the question that I would have of you, and I'll direct this to you, Dr. Sant, is should the Department of Energy's Building Technologies Office be doing more to help, whether it's develop, test, or certify the carbonate material? Should other organizations like ASTM International be part of this? You know, as we try to figure out how we go from getting the great ideas to real commercialization here, should our agencies be doing more in that regard? Other organizations as well.
So Senator McCoskey, thanks very much for the question. There's really maybe a couple of different comments to make. Number one, I think it's important to involve the Department of Transportation because they are over, above, and beyond the largest consumers of concrete in the United States. Being able to couple this with the Department of Defense for, again, obvious reasons makes sense because they're, again, the biggest users. I think if we can tie this in with an agency like NIST, as an example, you know, National Institute of Standards and Technology, I think it gives us a unified way to get sort of the biggest buyers and obviously the standards agency and get them to all work together and eventually flow all of that down into ASTM. The Building Technologies Office has historically not looked at primary construction materials, at least as I'm aware. They've looked at things like building envelopes and energy efficiency, but not really at primary construction materials. I think really starting out with the transportation agencies is a good place to start because anything that's accepted by a transportation agency is typically accepted downstream into the construction sector. That said, however, I think it's important to really think about setting unified standards. And, you know, I think creating databases is really something which I'll keep going back to because there are two parts to this. So one part is really the engineering performance. The second part is really the life cycle or environmental intensity of production and use. And we need to really harmonize both of these things together, which is something that we've not done. Maybe just as an aside, you know, going back to your earlier question, as we know, the oceans are the biggest sink of CO2 in the world. And beyond simply thinking about kelp as an example, you know, there might be some interesting opportunities based on work that we've been doing over the last several years, where there are interesting adjacencies where you can achieve carbon dioxide removal, but also produce things like hydrogen in the process. And hydrogen, as you know, is a clean fuel. So there might be opportunities to really couple this even beyond just what I'd say is biological forms to maybe even energy sources.
Very encouraging. Thank you, Mr. Chairman. I appreciate it, and I appreciate not only the witnesses being here today, but what you're doing to contribute and push out in these great areas of innovation. So thank you.
Thank you, Senator. And now we have Senator King by Webex.
Thank you, Mr. Chairman. Sorry to have been late to this hearing. I was at an armed services hearing talking about entirely different, but nonetheless very serious issues. It seems what I'm most interested in is timing. We're in a race, and we're in a race that we're losing right now. And how soon, let's put aside utilization of the carbon that we remove, and I want to focus on carbon capture in the burning of fossil fuels and carbon removal from the atmosphere, which is ultimately going to be necessary if we're going to win this race because of the persistence of carbon in the atmosphere. Dr. Anderson, give me some hard numbers. What are we talking about for when we have a carbon capture technology that, for example, would be cost effective on any fossil fuel plant? And the second question is, how far are we away from being able to actually remove carbon from the atmosphere, not capture it in the process of burning fossil fuels?
Well, Senator Kane, thank you so much for that question. Right now, given 45Q and a real concrete price point and price incentive, which is a bit analogous to the ITC or PTC tax credits on solar and wind, there's tremendous commercial interest today, given the technologies where we are today. The driving down the price curve, which as I mentioned earlier, I do believe there is a potential for continued decreases in the cost curve, requires getting it out into the commercial scale, and the commercial sector needs those concrete, financeable incentives to capture carbon. And so 45Q is a step. The follow-on steps would be the price of carbon and those price signals that folks can go to the bank. And so, in short, I'd say it's as fast as we can construct those projects that are applying to 45Q today. And then as they are deployed into the market within the next 10 years, we will be driving the cost of capture down, and I think we'll achieve a $30 price. As far as direct air capture, it's much higher up on the price curve. And so when it comes to the price paid for carbon, whether it's a 45Q tax credit, we have a longer way to go to drive down the cost of direct air capture.
Do you think that when we're talking about capture, that by the time the capture technology is cost effective, we'll be out of the fossil fuel, at least in the electric generating business? The president today is announcing a goal of 50% reduction in 9 years. So it may be that the technology becomes available at a time when there are no more fossil fuel plants. Is that a possibility, or will there always be fossil fuel plants?
I believe because of resiliency and reliability issues, and also considering the deployment curves of the non-fossil emitting electricity generation resources, as we move to higher and higher levels of deployment, we need on-demand firm power generating assets. And so those assets will likely be fossil energy with carbon capture moving into the future. We are in the midst of a lot of natural gas plants being built today, and natural gas with carbon capture has a great potential of providing that firm power in a carbon-free basis with carbon capture.
I fully understand the importance of backup power and to solve the intermittency problem. But again, we're talking about a 5 to 10 year time frame. We may see dramatic developments in storage or in a new generation of nuclear power, which could provide that backup. But it's certainly a dynamic market. I'm encouraged about the timeline on carbon capture. I'm discouraged about the timeline on carbon removal, because in the long run, that's going to be necessary. We could stop all carbon in the atmosphere tomorrow, and we'd still have a problem. As you know, we're pretty much beyond the tipping point.
Yes, and so that will perhaps we need different levels of carbon incentives to make it economical for direct air capture or other carbon removal technologies.
Do you believe that a price on carbon in some way, as some kind of carbon price and dividend, would be a important policy initiative?
Well, if we are to decarbonize our economy, we do need price signals that the private sector can run to the bank and are bankable in order to decarbonize. In terms of the policy mechanisms, there are a number of ways to get to the end goal, but some signal on carbon itself is necessary.
Thank you. Thank you, Mr. Chairman.
Thank you, Senator. Now Senator Daines.
Thank you, Mr. Chairman. Last Congress, we passed our bipartisan EFFECT Act that increases investment and, importantly, commercialization of carbon capture technology. And while the U.S. continues to lead in carbon capture research, as well as development, we haven't yet brought the technology to scale and the cost necessary for wide adoption. In the EFFECT Act, we set up a program for large-scale pilot projects at an existing coal or natural gas power plant. In fact, I believe that Montana is a great fit for one of these pilot projects. I have 5 letters of support from the community and businesses around the Colstrip power plant, asking for a project to be located to help keep and to grow the jobs in that area. Dr. Anderson, as DOE prepares to implement the authorities in the EFFECT Act, what will DOE be looking at for in a pilot project, and how can we ensure that the voice of Montanans are heard in that process?
Senator Mason, thank you for that question. As we move forward, the deployment of carbon capture and sequestration technologies under our carbon capture program, we have a number of projects under Carbon Safe, which has been identifying the subsurface resources available for sequestration. We're moving into a FEED stage, front-end engineering design, which would do the full-scale design of the integrated carbon capture and sequestration process for a number of our carbon safe FEED study projects. And what we're looking for is that fully encompassed design and the implementation plan. Then when it comes to deployment in large scale and being able to scale up to the commercial scale, again, I do believe that a lot rides on the signals like 45Q that would provide the financing for the private sector to pursue carbon capture projects.
Thank you, and I appreciate your thoughts on that. I think that would be helpful. We've got we think a wonderful place for it because, of course, it's a large operation, transmission lines that take care of moving energy across the Northwest. So we'd like it to be considered for sure. While it's important to promote federal investment in research and development, we also need to ensure companies have the tools in place to create and build those jobs. That's where Chairman Manchin's and my bipartisan American Jobs and Energy Manufacturing Act comes in. Our bill incentivizes companies to build the next generation of energy manufacturing in the U.S., and specifically in rural areas like Montana, and updating, of course, the tax credits. This includes clean technologies like carbon capture and utilization, renewable fuels, and coal to products. Mr. Atkins, how can companies like yours leverage tax credits like the one in our bill to create jobs in rural communities? I know they're very important to Senator Manchin and myself.
So I think tax credits are an integral part of any private financing. We look at trying to basically look at creating an equality with the 45Q credits so that perhaps there might be credits for not only just not using carbon emissions, but also capturing it. We've been working with NETL on some rather innovative technologies where we can take porous carbons, taking basically a gram of coal, and we can create 3,000 square meters worth of porous surface. That can be used to capture carbon. And that's the type of thing that we want to get private incentives from the government to be able to put into manufacturing in the private areas.
Yeah, I think that's what sometimes is forgotten. It's a very capital-intensive process with long-term payouts. It's something
and in many of these technologies, there's what's called the manufacturing valley of death, where you need vast sums of private capital to create manufacturing facilities to meet product ends, which in many cases are incented by the government.
Yeah, and I think that also it's also the certainty that's needed for these long-term capital investments that would be most helpful. But thank you, Mr. Chairman. I yield back my time.
Thank you, Senator. And now we have Senator Cantwell.
Thank you. Thank you, Mr. Chairman. Thank you to you and the Ranking Member Barrasso for holding this hearing. Happy Earth Day to both of you. And I certainly appreciate that there are many hearings across the spectrum today talking about R&D investments. And many of you know we're working on the Endless Frontiers Act in the Commerce Committee, and we certainly want to get technology, innovation, and commercialization right. I think this particular area we're discussing today about clean energy markets and more R&D into carbon sequestration and utilization is certainly worth more investment. So certainly appreciate that, and certainly appreciate the role of DOE in making sure that it's recognized in the future and making sure that we continue to empower it on these areas. I wanted to ask two questions. Mr. Beggars, what do you think that we've learned from what you've been able to do in Wyoming as it relates to the ITC, Integrated Test Center, and activities like the X Prize? What do you think we should apply from that to the future public-private partnerships? And I'm also curious to any of the witnesses. I think of our public lands, obviously, as a way to sequester some amount of domestic carbon emissions. And what else should we be doing in that particular area? The National Academy of Science estimated the U.S. can store an additional 500 million metric tons of CO2 per year through a mix of carbon-enhancing practices on cropland, grasslands, and forest lands. And so I think this is something that we also should be considering. So, Mr. Beggar, if you want to start with you, and then anybody who wants to answer the second part.
Senator, I think we've learned a lot of really important lessons at the ITC, and we feel like we bridge that valley of death role that was just mentioned. NETL and Department of Energy has a great graphic that sort of shows this timeline of technology development, and there was this valley of death between the small scale things coming out of laboratories and universities versus things at a 10 to 20 megawatt scale, which is 200 to 400 ton per day capture facilities that industry needs to see in order to feel comfortable that it's scaling up. And I think that's the biggest thing with the success of the Integrated Test Center is our utilities and the National Rural Electric Cooperatives Association is they're able to give us nudges, indications as to, hey, as ultimate consumers of this technology, these are things that make sense to us and fit into the economics of how we run our business. So I think that's important. I think another area is looking at environmental permitting, everything that goes along with it. As a research facility, each and every one of our tenants still need to comply with the Clean Air Act and receive permits and do things. So looking at things like a blanket permit waiver from the EPA for test facilities would be really helpful for teams like Carbon Built that came in that are academics that really have never dealt with permitting and things at that level of sophistication before that we had to help them with. And lastly, when you think about public lands, you're going to trigger NEPA every step of the way. And I look at, we have a...
I don't know, why would you trigger NEPA when I'm saying let's make sure we preserve big forests like the Tongass or other areas and don't and don't take away from that, so.
Senator, I'm speaking a little bit more broadly with industrial uses. Like if you're moving CO2 from, say, places that are sources in the Midwest to the West where you have really good geology for geologic sequestration, so.
I'm talking about just understanding our current natural benefits. Anybody else on that point?
I would argue that one way to also look at this might be to consider not just the public side, but the private side, because if we can incent private industry to use other means of sort of separating the C and the O2, we've proven that there are uses for the carbon. So I think there's more than one way to skin a cat, and I think to the extent that Congress can help incent research and development from the private side toward this, I think that might be very useful.
We heard another voice somewhere.
Senator Campbell, I'm happy to say something about the X Prize. I think, one of the things that we really liked about the competition and sort of just thinking about the general idea of innovation, being able to work towards a defined goal is always really good. But I think what's really required as we think about innovation is an acceptance for failure, right? I think we've gotten overly focused on sort of just desiring success, but in innovation, success is never assured. And I think being able to accept failure and being able to build programs that sort of reward failure as a step in the learning process is, I think, something that we fundamentally need to think of as we approach large-scale R&D, especially the kinds of crash R&D programs that are likely to be needed to make a difference in a decade.
Mr. Chairman, if I could, on that point, because this is so important to this broad debate that we're having today, I think there's a really big philosophical question that we have to address here. So to me, you know, if you're talking about the private sector having its experiments and having failures, I'm all good with it, okay? If you're talking about us doing basic research and having failures, I'm all good with that too. But if you're talking about taxpayer money and you're picking certain technologies as winners and losers and then finding out, or maybe even building actual testbed manufacturing facilities, and you basically lose, I'm not sure taxpayers are good with that. So I think that we want to proceed on some of these questions because, as Mr. Beggar said, the test bed in Wyoming did give us some answers. And we are at that stage where we want to take tech transfer and make it more robust. But I guarantee you, the minute we have a Cylindra or something like that, the public, the taxpayer dollar, isn't going to be down with, you know, we failed. So I think this is, we just have to get some context here. I'm just trying to understand what context are we going to have to the government funding actual, what I would call translational science and having failures. I just don't know how to categorize that because now we're dealing with taxpayer money, not investor money. And I do think my constituents, who are a very, very big innovation economy, I would say there's hundreds of thousands of people who invest in these companies in my state. They're very sophisticated. You know, they definitely understand risk, but I don't know that they understand that that risk could be taken with taxpayer dollars. So if anybody can help me out on that, I would love to hear an answer because we're in the midst of trying to do this right now with this big EFA bill.
You know, I don't have all the answers. I mean, this is definitely an important point that you raised, and of course, we want to be good stewards of taxpayer money for sure. But I think the reality is that, you know, not all questions can be answered until we get to full commercial scale, and I think that's just sort of the nature of the beast. I think between a combination of being able to de-risk technology sequentially as we come up the TRL is something that we need to do. Being able to develop really robust vetting processes that will give us a line of sight to understanding if something might fail is an important thing to do. But I think there's also a market aspect to it because, you know, if you create a market demand on the other side, it's highly unlikely that you would end up with failure because if there's a demand that's assured and the supply that's coming online, that generally leads to a favorable outcome. And so, you know, I think I don't disagree that this is sort of a bigger and a broader issue, but we maybe need to think about it a bit more expansively as simply just sort of a single case at a time.
Thank you. I know I'm way over my time, Mr. Chairman, but this is such an important, timely question, and I do think it's, you know, important particularly in this particular area too.
Well, thank you so much, Senator Cantwell, for your continued interest in what we had talked earlier while you were here of, you know, the traveling that we've done to look at some of these research projects that were done, and there's Dr. Gahn, who's actually won the award, the X Prize, where we looked at the research done overseas. So thank you. Senator Cassidy.
Hey, thank you all. Splitting time between hearings, so if I ask something that's redundant, I apologize. Dr. Anderson or Mr. Beggar, you know, in my briefing material, it spoke about carbon dioxide from effluent, for example, or whatever, being used to create methanol. Another example was being used to make ethylene. What is the cost basis, do you know, of making methanol from CO2 or as opposed to that which is made from natural gas? I just say that because that relates to commercial viability. We want to have some place to make, you know, to do with all this CO2, some way to use all this CO2. And I'm just curious about that. Nothing else but curiosity right now.
So, Senator Cassidy, if I might jump in, you know, certainly because CO2 is thermodynamically more stable, it is moving back up the oxidation chain. So it is not more economical to go CO2 to methanol than it is methane. However, under certain contexts, because of if as we move down the deployment curve of intermittent renewables, there are times in which we may end up with curtailment situations under renewables with excess electricity. And in terms of the storage options, there's battery storage for grid scale, but there are also thermochemical storage opportunities. And so if you couple an intermittent renewable generation facility with direct air capture, you might have a source of CO2 that's effectively free and electrons that are would otherwise be curtailed that would allow for the chemical storage. And so it's part of the integrated energy systems work that we have going on with Idaho National Lab and NREL to understand the full dynamics of those economics, which are simply more complicated than just starting with methane or starting with CO2.
Does that suggest that you need proximity of the generation to the plant, which is converting to the direct air capture, for example? Or can it just be excess electrons on the grid? And I'm just curious, can you have a start and stop, you know, kind of a rapid gear up? We're going to start taking your CO2 and turn it into methanol, knowing that this may be TBD, but what you're saying is very intriguing to me.
So, some is TBD, and it certainly doesn't have to be proximal, but at least with direct air capture, you can move it almost anywhere, and you can eliminate line losses if you do put it proximal to the intermittent resource.
My understanding was that direct air capture works best in warm, humid environments. Coming from Louisiana, of course, that perked my ears. Right. But are you suggesting that we could do just as well in some frigid northern place beset by snow and ice?
Well, it might not be as efficient, but there is certainly a demonstration facility in Iceland, and one of the direct air capture demonstration facilities that's doing pretty well in Iceland as well.
The ethylene. I see that there's a demonstration project with Occidental using CO2 to make ethylene. Again, is that the same principle that you've been discussing?
It is effectively the same principle. CO2 to a syngas with water, and then from syngas you can make almost any of the hydrocarbons.
Just a question of whether or not you have adequate energy input, whether or not your net carbon profile is better off with or without it. A fair summary?
Well, and that absolutely, because you are climbing up the energy chain, going from CO2 to a hydrocarbon, and so it requires some excess energy.
Dr. Sant, again, I apologize if someone's already asked you about this, but I think it's really interesting, your technology. If you use CO2 to cure your concrete, how much does that save on your CO2 profile relative to traditional Portland concrete, cement?
So, Senator, we've spent a lot of time looking at this, and if I give you an example around something like a typical concrete block, which is one of the products that we're in the midst of producing, we can reduce the carbon intensity by between 50 and 70% compared to a traditional concrete. So it's really a pretty significant reduction.
There's a lot of advocates for carbon taxes, which it seems like if you're going to have a border adjustment tax for a carbon tax, you'd have to take into account not only the energy inputs, but also the concrete that would be required to build a particular facility. If you're really going to, as well as the vehicles going back and forth, all that sort of a thing. So if somebody was going to build a facility in the U.S. or overseas using your technology, the logical extension is if you have a border adjustment tax or a border adjustment credit, is that somehow this would be amortized over a certain period of time, the amount of carbon that the constructors saved from using your technology. Again, I'm thinking out loud, but I suspect you would agree with that.
So generally speaking, so of course, a border tariff adjustment may or may not make sense depending on whether you're dealing with an import question or not. But I think the short answer really turns out to be, it really depends on the price signal on CO2 and whether that price signal is best valued over an amortized basis or whether it can be recovered at the front end. If you can recover it at the front end, I think you want to do it all up front. On the other hand, if there's a reason to sort of make a bet on the forward price curve, well, then you might choose to amortize it so that you can essentially value it into the future.
Well, I appreciate your testimony. I yield back, Mr. Chairman.
Thank you, Senator. And now we'll have Senator Marshall.
Well, thank you, Chairman. And my first question is going to be for Mr. Atkins, and it has to do with a tax benefit that I believe both the oil and gas industry and the coal industry benefit called the percentage depletion allowance. One of the prerequisites here is that coal is a very cheap product, and there's so many opportunities for it. And it's my understanding in the infrastructure bill that's coming before us that we're considering that we would lose this percentage depletion allowance. When I think about tax benefits that the different energies receive, I think about the oil and gas industry, coal industry bill was 1x. Probably the wind energy receives 7 times that, and solar maybe 70 times that from a benefit from the federal government. And I always preface this by saying, look, I want to leave this environment cleaner, healthier, and safer than I found it, as do all of us in the room. But I can't drive the cost of energy up so much that a working family can no longer to put gas in their car or to pay their electricity bill. Am I making some reasonable assumptions there when you think about tax benefits to the different industries that really coal, this may be the last thing standing that coal gets?
Yeah. I think, all industries like to play on an even playing field. And I'm afraid, as we've gone on over time, that playing field keeps changing. Obviously, today, the thumb on the scale is obviously weighted toward renewables. It's being taken off of any of the fossil fuels. And I think the way we've tried to approach it, obviously, we are in favor of all incentives that can be given for any form of production in this country. I don't care whether it's wind, solar, coal, fossil fuel. They all create jobs. They're all critical to our national strategic interests, and they should all be fostered. What we've tried to do is to sort of take away from the equation, the notion that somehow carbon is bad. Carbon is not bad. There are issues, obviously, when you combine a carbon with an oxygen molecule and you have CO2, and we understand that. So we're trying to basically move beyond that thesis and really step outside into something modestly transformational where we say, all right, let's look at the carbon inside of something that is today in disfavor, frankly, and see if we can turn, I hate to use this phrase, sort of a diamond in the rough. So, coal is a diamond is basically coal that's done well under pressure. So essentially that's what we're trying to do.
Yeah, coal gives us a pretty big bang for the buck when it comes to energy. There's no doubt about that as well. I think my next question is for Dr. Anderson. Dr. Anderson, we're hearing about more technologies here today and taking carbon and just turning it into some incredible things from a manufacturing process. And I had the opportunity recently to sit down with the company Carbon Solutions Materia USA out of Pennsylvania. And it gave me a piece of carbon and then gave me the fiber that they're able to turn it into and the graphite as well. I mean, I think it could be transformative when we think about the opportunities for high-speed fiber, making carbon into high-speed fiber, making semiconductors. My goodness, other countries are dominating all these areas, and we have to bring these back to the United States. So, Dr. Anderson, I guess my question, are you committed to helping the Department of Energy bring these technologies to fruition and help Americans out here bringing these supply chains back into the United States?
Yes, we are. And in fact, I think that there is one opportunity here that we may not have stated. There are many communities across the country, coal and power plant communities that have been impacted and will become even more impacted as we move forward in the energy transition. And as we create opportunities for adding value from the coal resource that are in these coal communities, it turns out that many of these supply chains are much more efficient if the processing facilities are moved closer to the mine mouth. And so, in fact, when we look at the replacement of jobs that Mr. Beggar was alluding to earlier, there is an opportunity to add value, like you were mentioning, these high-value products by bringing the supply chain back closer to the mine mouth and creating additional jobs in addition to replacement of tonnage, as was spoken of earlier.
Is there anything more specific that you can describe what you see the role the Department of Energy is in bringing this to the real world?
Well, and so it is as an applied laboratory and the government-owned, government-operated laboratory within the DOE that manages program across fossil energy, energy efficiency, and renewable energy, CESAR and OE. It is our job to make sure that these technologies find their way into market and reduce risk and have the appropriate technology transfer pathways for all the technologies we work on, including coal to products and other carbon products and CO2 utilization. So it is firmly within our mission to try to get these technologies into the hands of the folks who will put it into commercial practice.
Thank you, and I yield back.
Thank you, Senator Marshall. Senator Hoeven.
Thank you, Mr. Chairman. Dr. Anderson, how important is collaboration between NETL and its partners like the Energy and Environmental Research Center, ERC, at the University of North Dakota in terms of developing the technologies that are going to help us crack the code on carbon capture and sequestration? Could you talk a little bit about the importance of those partnerships and your commitment to them?
Yeah, so partnerships in general is where we live. We have over 600 partners across the country, but there are some that are committed and share a mission with us, including EERC. And so the ERC in North Dakota is really critical to a number of our technology developments across rare earth elements, gasification, coal to products, unconventional oil and gas as well, and certainly last but not least in CO2 sequestration. And so there are, partnerships is really the name of the game for us because it takes the entire value chain and skill set of folks across the country to work and tackle these challenges.
And are you confident that we can crack the code on carbon capture and storage from our coal-fired electric plants, and that's an important part of our energy mix?
I am confident. The EIA in the United States and the IEA internationally, time and time again have shown that if we're going to decarbonize the electricity sector and the economies, we need the technology of carbon capture, utilization, and storage. And so it will be a critical component to our pathway to decarbonizing the economy.
And not only if we meet it here and make it happen in this country, then the rest of the world will be adopters too. And there's a lot of coal-fired electric in other countries. So that's a huge factor, isn't it?
Yes, absolutely agree.
Thank you very much. Mr. Beggar, in terms of trying to help make this happen, in terms of cracking the code on carbon capture, we worked on help through 45Q, the tax credit for geological storage. We've worked on loan guarantees through DOE and RUS, and we've worked on funding help from DOE for the equipment that needs to be put in place to make it happen. Those are the kind of incentives and programs we're trying to bring to work with our industry and the states to make this happen. Tell me your view on how we continue to enhance those tools to make CCUS happen.
Senator, I believe we need to make sure that we have the infrastructure in place within the U.S. to actually support these technologies. I mentioned earlier that for large-scale technologies above, really a megawatt and a half, to scale up to that 10 to 20 that people see, we send technologies and U.S. taxpayer dollars to Mongstad facility in Norway. We have that ability in the U.S. We should be building up facilities, 2, 3 of those that can do that here. It's all about scalability and access. For a lot of smaller technology developers, they may not have access to the National Carbon Capture Center or EERC. So what are we doing to put the tools or sort of grease those skids, grease that glide path to technology development? And I think a critical part of that is not just the programmatic funding to do the things that we need to do, but the bits and pieces on the back end to provide that platform for these technologies to scale.
How important is it that we enhance 45Q with the direct pay option?
Senator, I think it's going to help really be a game changer. Right now, for 45Q, if you're going the tax equity financing route, you're only going to see a fraction of that. So a $35 for EOR, I don't know what the exact market is, but it might only be $17 or $18. So making sure that money actually ends up in the hands of the developers and the people moving the project and not the financiers, I think would be really important.
Yeah, for that direct pay option, 45Q, the CBO score is less than the 10-year score is less than $1 billion. And that, as you said, would be a game changer, right?
That's correct. Just a week ago, I was speaking with a large EOR development company and just looking, they were kind of walking through their thought process and how they value and look at projects. And they go, you know, a $5 to $10 differential is more than make or break. It's really, are these things profitable or not? And they said the direct pay option would be something that could make up that gap.
Yeah, absolutely. Thank you so much. I appreciate it. Thank you, Mr. Chairman.
Thank you, Senator. And I think we have Senator Hickenlooper.
Hey, how are you doing?
Good.
Sorry, I'm a little bit late.
No problem. Wrap it up.
I think this is a great panel. I've been dodging in and out, so if I'm asking a question that is redundant, I apologize. And I think having so much thought about carbon utilization, which obviously has the potential to be a giant market opportunity, but at the same time, we're working to build our capacity to permanently store CO2 underground. Dr. Anderson, the National Energy Technology Laboratory awarded funding in Colorado to capture emissions from a cement facility, which could then store that CO2 permanently underground. How should we be thinking about the relative value of permanent sequestration versus the CO2 utilization we've been hearing about today?
Well, Senator Hickenlooper, thank you for that question. I think that the value of decarbonizing the economy, it seems like one carbon avoided into the atmosphere has its own inherent value, but as we drive down the cost of the carbon removal and create the markets because of the availability of low-cost CO2. CO2 is not free today. And there are opportunities then to utilize it into other products that are also permanently sequestered. And so one of our, from our standpoint, one of the big areas for us in our research program in subsurface sequestration and permanence is to drive down the risk of permanence as well. And we have a multi-laboratory consortium called the National Risk Assessment Partnership to help drive down that risk for the assurity of the permanence of CO2 sequestered in the subsurface.
Yeah, no, and I love that collaborative effort that you have on so many of these. You've talked a little bit about the 45Q tax credit to provide a revenue stream for capturing carbon so as to incentivize the development of these technologies and to move us closer to getting to carbon-free or achieve negative emissions, I guess you call it. What effect would have if, and a lot of people are talking about some sort of a price on carbon, let's call it a fee and dividend, but it could be any of a variety of proposals. How would this help accelerate that emerging field of carbon utilization?
Well, I think that with the 45Q, and I made an analogy earlier that it is a bit more similar to the investment tax credits and the production tax credits that we see on renewable deployment. And so I think that as part of a whole portfolio of incentivizing the movement and deployment of the new technologies on the market, like 45Q does, like the ITCs and PTCs do, it is really important to help incentivize that movement into the market. And then if there is long-term certainty that can create the financial incentives, and we did have a discussion with Mr. Beggar just recently regarding how some of those payments don't go straight to the developer, but at least some certainty around the future of carbon to provide the long-term incentives of large-scale investment for CCUS is really important.
Yeah, no, exactly. Mr. Beggar, you talked earlier about some of the issues around capturing CO2, and this notion of carbon sequestration, which seemed, a long shot not so many years ago, clearly can be done, and the cost continues to come down. There are also infrastructure needs associated with capturing CO2 and transporting it to permanent sites or locations for reuse. Can you speak to the job growth and economic opportunities associated with the build out of this kind of infrastructure?
Certainly, Senator, you just look at what it would all entail. I mean, really, the management of carbon is taking it from sources and putting it towards sinks, and the sinks can be a lot of different things, whether it's, geologic sequestration, enhanced oil recovery, to products. But that's the process is we need to be able to capture it and move it, and capture could be on a power plant, it could be direct air capture. I guess I look at it in terms of, any other sort of industrial project. Certainly a buildup of an industrial facility could be many thousands of jobs. Then you look at pipelines. I think it's pretty well documented the number of jobs that are associated with pipelines to move it from point A to point B. So really, particular projects is going to be thousands of people. So I think there's tremendous value in the build out.
Yeah, well, I love the work that you guys are doing. Actually, all of you. I think it's a broad cross section. Takes me back to my, I did take do a research project, I guess 40 years ago, on using salt as a storage vehicle, salt formations as a storage vehicle for radioactive materials, for carbon, for CO2, things like that. Anyway, it's good to see that these things go in full circles. Anyway, I'll yield back my time. Thank you, Mr. Chairman.
And thank you. And Senator Brasso?
Terrific hearing, Mr. Chairman. Let me thank you for bringing in these wonderful guests to talk about some of the most exciting research that I think is happening anywhere.
Well, thank you for bringing all the talent you brought from Wyoming, too. Let me just say to all of you, it really has been a great hearing. I want to thank you, but I'm also challenging you all to tell us how quick we can get to 2030's target date and what it takes if we start today to ramp up. And I'm also very encouraged about those of us who have retired coal areas where coal plants have closed or power plants have closed, that this could give us a whole new manufacturing renaissance there that really fits, rather than trying to go into a coal area and bringing some type of manufacturing that doesn't fit with the culture. So that is so exciting right now, but we really look forward to hearing from you all. And I would say this, the members will have until the close of business tomorrow to submit additional questions for the record. So again, thank you, each and every one of you.